All right, guys, we're going to take a minute and look at actually doing some GNM coding. And so we're going to walk through a program just showing you kind of how this works. And then we'll stop there, and then we'll come back and look at another coding option after that. We're going to start with absolute, and then we'll come back in another video and look at relative. All right, so anytime we go to do a part, the first thing that we need to do is we need to actually do some planning. And so that's what we're doing here. We're doing some really simple, we just want to do some initials. And so they're using MD as their sample initials. And hopefully what you're noticing is a couple things. One of them is that every vertex, every corner point is going to be labeled. So think of this kind of like a connected dots machine or, puzzle. And so each of those is a dot that we're going to go from point to point to point to point and give those as coordinates for our code. So over on the right side, we have a table listing what all those points are. And so you look at A, point A is over here at a half and a half. This grid is a 1/4 inch grid. And so this is over 1/2, up 1/2. Everything is in reference to our origin. And one of the nice things about this is you can actually set the origin wherever you want. Now we are going to try to be consistent with it. So we're going to tend to pick this bottom left corner. If you're looking at it from the top view of this part, that would be our bottom left corner. We're going to tend to pick that as our origin. And it's the top edge of the part. And the reason we pick that top edge is because that is going to be 0 point. So it means anything above that would be a Z position that's not in the material. Anything below that would be cutting. So anything negative is a cutting height. Anything positive is a height where we're not going to be cutting material. So we like to set that as our origin, just so we know if it's negative, it's cutting, positive, we're not. And then because of where we set the origin here in the bottom left, that means anything along the X direction, which is this front edge, is going to be positive X. Anything along that back edge right there, that is positive Y. So we're just trying to keep all of our numbers positive for the X and Y. And then of course, Z is going to be positive for above the part, negative if we're cutting. So again, we're just going to list out all our numbers, so all of our vertices here. We've got a X and Y coordinate for each of those, so our X coordinate and a Y coordinate for each of those points. And so, B we've got up here at over 1/2 and up 1.5. And so you can kind of look through and see all those points. One additional point that might be of interest to you is this point I. Point I is there not because we need to actually travel to it, but that is going to be our center point for this arc. So when we make this arc, we need to know its center point. That's one of the things we were looking at in the last videos for those GNM codes, is that you have GO2 or GO3. Both of those codes will allow you to do an arc, either clockwise or counterclockwise. But you either need to know the radius or you need to know a center point. So we're going to look at I as our center point. Now you could use radius for that as well, but if we're using center point, we need to know that point. All right, so let's take a look at what that program is going to look like. So first thing that we do on every program is we need to do some kind of basic setup. And so our first line in this code is saying, here's our number block. It's line 1. So N1 is number block 1. And we're doing 2 codes here. And if you remember what those 2 were from our last video, that would be great. If not, it's over here in our comments. This is setting that we are absolute coordinate system. So G90 is absolute. G91 was relative. So G90, we're saying, for this program, we're using absolute coordinate system. And again, what does that mean? That means everything is being referenced from this origin point right here. That is our origin. That's where everything's being referenced from. So when it says absolute coordinates, it's going from this point being 0, 0, 0. So everything is going to be measured from that origin point. And so our X, Y, and of course, up and down to Z. And then G20 is just telling us what types of units we're using. So in this case, we're using inches. You could do millimeters as well. I can't remember the code off the top of my head. I think it's G21. But there is a different code for millimeters. We're going to stick with inches for right now. But you can definitely use millimeter code as well. All right, so the second thing we want to do is we need to tell it not only what coordinates we have, what type of units we're using, but we want to let the program know what kind of tool are we using, because our tool setup, and we haven't really talked about tool setup, but when you're setting up all your tools have slightly different links to them just because of the way you're setting them up. When you put them into the tool holder, into the collet, they're not all going to be the same exact length. And so one of the things that we have to do in our setup is we need to go through and list out what all of our tools we have, and then in our machine it needs to know the offset. And the offset is basically how long is each tool going to be. And so what we'll do is set a reference tool, and that reference tool will be kind of the baseline for everything, and then everything else will be relative to that one. So if the one that we put in there is 1 inch long and another one is 1¼ inches long, then our offset for that second one would be 0.25, saying it's 0.25 longer than the other one. And so that just allows us to get the proper height when we start cutting. If we don't know how deep to cut, if one tool is longer than the other, we're going to run into problems with that. Now, a lot of the newer, a little bit fancier machines that you're going to run into will have a kind of touch off point where it actually will measure that tool height automatically before it starts cutting. So you don't have to worry about that. It'll do the measurement itself. But for what we have, we need to actually have that put in there. So one of the things that has to happen is we have to measure our tools and know like what those offsets are. Okay. So first thing we're going to do is we're going to use our M06 code. M06 is just the tool change code. That's what it's doing. And then T1 says we're going to load tool 1. And of course, we'd have to know what tool 1 is. In this case, tool 1 is going to be, I think, an 1/8 inch bit is what we have in there for tool 1. And then one other setup thing we have to do is we need to turn our spindle on, and we need to set our spindle speed. So all these things are going to be one of the first sets of code you're going to do. So line 1, 2, and 3, we do that pretty much every time we write code. We need to set our units and coordinate system, choose our tool, and then we're going to go ahead and turn the spindle on and set our spindle speed. In this case, we're setting spindle speed to 3,000 RPM. So that's pretty fast. It's not as fast as it can go. It's kind of a mid-range speed for the machines we have. All right, and then once you've got all those things, we're going to just basically try to get our tool to the correct location. And we're always going to move XY first. So in this case, we're going to take and move with this rapid motion. This is the G00 is the rapid interpolation. It's a rapid transit. It's just going to move quick. That's just good for getting around when you're not cutting anything. And so we've got basically we're moving this right above point A. So we're not cutting point A. When you do the tool change up here, it's going to move up to a safe tool change location. So it's going to move basically the Z height up to where you can actually change the tool. So that's where your tool should be right now. It should be up in that elevated position. So what we're doing here is we're just moving it horizontally. We're not moving it vertically at all. And we're just trying to basically hover over where that initial starting point is going to be. That's what we're doing. And so we're going to get it right above point A, and then we're going to come down. And this is the really important step. It's not that you have to have this step, but it's really a good idea to have this step because A, it takes a while to move the tool otherwise, and B, it just kind of gives you a visual to see if things are working correctly. So what we're going to have it do is move rapidly down to Z of 0.1. That's 0.1 inches above the part. That's kind of what we call our safe height. We know that if we're up out of the material at that point because the Z is positive. And so we want to move quickly to there, and then we're going to have it stop there. Now, it's not actually going to look like it stops, but as far as we're concerned, programming-wise, we're having it stop at that point. Now, our very next command is then going to be to continue on down into the part. So you're not going to really see a pause, but what you will see is a change in speed. So it's going to come down very quick to 0.1, and then when it gets to 0.1, it's going to slow down and then continue down in an actual cutting motion. So now we're going to G01. So this is an actual, straight line interpolation. We're going to move in a straight line. We're just translation motion down to negative 0.0625. So we're going down a 1/16 of an inch into the material. So it's going to be down a 1/16 of an inch below the surface, which again, 0 is our surface. And the one thing I hope you notice here is this F. F is feed rate. And so we're setting the feed rate to 9 inches per minute. Our normal feed rate for what we're going to be doing is 18 inches per minute. So we're just saying, since it's a plunge cuts, we always want to run a half speed. That was from that speed and feed video and PowerPoint we did before break. So speed and feed, when you do a plunge cut, it's going to be half the speed of a regular horizontal motion. Okay. All right, so this is the first time we've actually cut into the material, and we should be right now at 0.5 for X and Y, and we're down a 1/16 of an inch below the surface. So we're cut basically just like a hole in our material at that point. And so from here, everything we're going to do at this point is just going to be tracing out the letters. So think, connect the dots, etch a sketch, however you want to think about this. We're just moving from location to location, and we need to tell it how to get from point A to point B, literally in this case, because we are going from point A to point B. And so we're at A now, and if we go back, and I'm not going to go back, but if we went back and looked at our chart, we would see that point B is at 1/2 and then 1.5. So we need to change our XY location to go to that new location. So we're going to do that next. And so we're going to say, where do we want it to go? Well, we want it to go in a straight line. So again, G01 is our code to say it's a straight line. And we're just going to keep numbering this up as we go as far as our number block lines. So you're going to keep incrementing that up as you go. We're not going to talk about that much, but you can see that's what's happening. Okay, straight line code. We're going to that next location. So 1/2, 1.5 is our X and our Y. You might be noticing up here, like here I have X and Y, but no Z. Here I've got a Z, but no X and Y, no X and Y. This is what we talked about in those earlier videos about being modal. If we don't mention it again, it's not going to change. So we don't have to keep telling it to keep the spindle speed at 3,000. Once we set that, it stays 3,000 all the way through. We don't have to tell it what the Z value is, because it's going to stay at whatever Z value it already is. Now, if we have a specific height we want it at, we could put that there. We usually try not to, again, move horizontally and vertically at the same time. So we probably wouldn't do X, Y, and Z all at once, but we could do that. So here we're making a horizontal move, making a vertical move, making a vertical move, horizontal move, but we do not have to continue to tell us what Z it should be at. It's going to stay at whatever the Z it currently is. It's going to hold that value. Okay. One thing we do have to do, though, is we do need to change the feed rate, because now that we're making that horizontal cut, we can go faster, and we want to go faster because we want to get that good chip load. We want to make sure that we're not cutting too slow or too fast, but we want to set it to the proper speed. So again, the feed rate for horizontal motion is double that of a plunge cut, or normally we do it the other way and say the plunge is half the horizontal. So now we've basically gone to point B. So this is what's going to happen here. Excuse me. So we've gone to point B. And then from point B, we want to go to point C. So that's going to be our next point. And again, we're just putting in the X and Y coordinates, and we're saying G01. G01 is going to be that linear translation, that linear interpolation. And so it's going to go straight from this point to that point and make that cut. And again, we don't have to put the feed rate in again because we've already told it what it is. It's going to remember that feed rate. That's a modal value. So it's going to remember that value, just like it's remembering the Z value as well. So we're just going to continue to trace out the rest of that letter. So this is point C, we'll go to point D and then point E to get the rest of that M. So there's the point D and there's the point E. And here's where we have to make a change, because we think, okay, well, what do I want it to do now? Well, I want to get from D, or from this letter M that I've drew the first time. That was my first letter. I need to get from there to my second letter, which is the D. And I don't want it to cut that. So I need to come back out of my part. So what we're going to do now is we're going to raise our Z value back up to this safe height of 0.1. Now you can go higher than that if you want to, but you definitely want to go to something out of the material. You don't want to go to 0, because then you're going to potentially be scraping across the top and leaving marks. So you want to get it up somewhere safe. 0.1 again should be a good value. You could go higher if you wanted to. It's just going to add a little bit of time to your run, because it's going to take longer to go to a higher height. So here we go. We're going to come up to Z1. Again, we only need Z of 0.1. We only need that one command because it's not changing the XY. The XY are staying the same. We're just going vertically upwards. And so we're going to move upwards that way and use the G01 because we are not actually cutting anything, but we're still moving where we could be cutting. We'll be still in the part. So we want to use that slower speed while we're doing that. We didn't change the feed rate here because we're not actually cutting. Normally, again, if we're doing vertical motion, we want to do half the feed rate. But in this case, we're not, because we're not actually cutting anything, but we are going to go the slower speed, not the G00. Okay, so now we want to move over to where we want to start our next letter, and then we'll come back down into the part once we get to there. So we'll move over. Here's the location of point F, which is where we want to start our next letter, which is the letter D. And I can't remember which way they're going to go with this. We'll see if they do the line first or if they do the arc first. But we're going to go down to point F. We're going to go back down into the material. So we're going to go down back to that negative 0.0625. So we're a 1/16 of an inch in. Feed rate's again 9 because we're actually cutting material. And we're using the G01. And then we're going to make our next cut. So let's look and see which way they went. Okay, so they're doing the straight line cut to H. And so we're going to, again, all this is very repetitive. Setting the XY coordinates, changing the feed rate again because we're doing horizontal cutting. And that's nothing too big. We're going to go to point H. So at this point now, we just need to make an arc. And so we got to think about, okay, which way does that arc need to go? And without pulling that all the way back to the dill, we'll just look and see which way they went. All right, so they did G03. That's counterclockwise, which means they're coming this way. So we're going counterclockwise from the bottom up to the top. And so what we need to do then is we need to look at where do we want it to end. And so this is going to be back up to point F. So here's point F. We're going basically back to point F. That's our X and Y coordinates. This is our end point. So again, when we do the arc command, you do your end point. And then we need to tell it what the radius is or the center point. And so they're using the center point method here. And if you remember when we did center point, we talked about that in that code. Center point, we use INJ for your X and your Y for center point because we can't use X and Y because we're already using those for the end point. So they've used INJ. And if we were using a Z, we'd use K as the coordinate for the Z. If we were using that, we aren't going to actually need that one, but that's what we'd use. And so we'd have our center point was point I on our picture, and it was at 1.751. So it's just saying, do an arc starting from my current location, which is up here, go to this point around this center point. Now, one issue we do run into, and when if we were actually coding this, we have to deal with it. Since we're not actually going to code this, it won't matter too much as far as what you turn in, but you do have to make sure that this is actually the center point for these 2 points. So if you put something that's slightly off, and sometimes that happens, you're going to get some errors. Now, it will try to cut it still, but you might get some weird results if your points are a little bit off as far as not quite being the center point. So just be aware. We definitely want to make sure we're putting this in correctly as far as it being a center point. All right, and then next line, we're going to then, now that we've completed our letter, come back out of the part. So we're moving up to our safe height again. Turn off the spindle because we're done cutting. And so this is the other part that we do. So we have a beginning part that we do every time, and we have an ending part we do every time. So our ending part, we're going to turn off our spindle, just make sure we're safe to go on to our next operation. And then this is where we're going to move to a safe location. So they're going to do it in 2 steps. They're going to do one, the Z motion, because again, we don't want to move horizontally and vertically at the same time, just for safety's sake. So we're going to vertically move up to 2 inches above the part. And again, this is a absolute coordinate. So this is 2 inches above the top of the actual part because the 0 height is the surface. So we're moving up 2 inches from the top of the part. And then we're going to move to X4, Y3 as kind of a safe location. Again, we just want to kind of move to a place where the bit isn't directly over our part. So when we get in there, we need to start taking it out, working with the vise, that sort of thing. We don't have that bit just hanging right over the top of where we're working. That's just safety's sake. And you can use different coordinates. That's just the coordinates that they use for the mill that we have. We might find that different coordinates work better. And it doesn't really matter what those coordinates are as long as it just gets out of the way of what you're doing. But again, vertical first, and then we're going to move horizontally. So we're going to do that in 2 separate steps. So your part will move up and then over to the side. And we don't really care about what the direction it goes horizontally as far as, does it go left and right or front and back? We can do both of those at the same time. We just don't want to do vertical and horizontal. And they're using the GCodeAbsolute command because we're going to go fast because we're not cutting parts. And then we end our code with this M02. This is how it knows that it's reached the end of the code. So this is like closing off your robot C program with the curly brace at the end of your main task. So it's just saying, hey, I'm done. You've reached the end of code. Nothing should happen after this. So if you put anything after this, it should ignore it because this is the key mark to say this is the end of my program. Okay, so that is one full program that doesn't do a whole lot. We just trace out a couple letters, but that is one full program in G-code. And this is going to be what I'm going to have you guys do, is write your own G-code for absolute programming. And we'll look at what that looks like with relative in the next video. All right. Thank you very much, guys. We'll talk again about relative in the next video. Just keep an eye on the assignments. I'm going to have an absolute value or absolute programming assignment for you guys to work on, and then also a relative one. All right. Thank you.